The Research Institute for Analytical Instrumentation from Cluj-Napoca means modern analytical instrumentation and advanced analytical methods. The institute has as objectives research, analytical methodologies elaboration for a wide range of samples, design and construction of laboratory analytical instruments, performing of chemical analysis, and providing services of information, advice, and representation for business. The research activity directions are oriented towards fundamental, applied research, and experimental development. The main fields of research are environmental protection, assessment of microbiodiversity under the impact of global change, safety and food security, technologies modernization, clean technologies, bioenergy, and biomass. The Institute puts high emphasis on technology transfer in close correlation with its own research strategy. We invite you on a virtual tour of our institute to present the latest generation equipment and devices existing in our laboratories. The ELON DRC2 inductively coupled plasma mass spectrometer can detect almost any element from the periodic table to concentrations as low as parts per billion. Samples can be from a wide range, from water and soil to blood or meteorite samples. It offers data about pollution agents in the environment, gives us a better understanding about how various medicines interact with our bodies, and also uncovers secrets hidden in space rocks older than Earth itself. If the ELON DRC2 uses a single quadrupole as a mass filter to be able to extract and detect ions from samples, the latest generation ICAP TQ instrument has an extra quadrupole for a better management of atomic interferences, helping us receive even more reliable results. The instrument is also coupled with an HPLC module for organic and inorganic elemental speciation, allowing us to receive even more in-depth information about the sample and better understand the polluting agents from our environment. Non-destructive analytical tool for quickly identifying the elemental composition of a sample that can be used in restoring damaged or old artworks or checking the composition of an alloy with results available in just a few seconds. We used it to identify fake Roman coins to assess the age and location of an old medieval weapon or to confirm the use of unknown archaeological items. The scanning electron microscope is a versatile multifunctional tool which allows to get images of the material's surface structure and morphology with a few nanometers resolution. It also gives qualitative and quantitative chemical information. It is used for the evaluation of zeolites, nanomaterials, algae, bioplastics, etc. Patented hybrid triple quadrupole linear ion trap technology takes you far beyond the capabilities of any conventional ion trap, enabling you to screen, identify, and quantify proteins or small molecules in a single analysis. By combining true triple quadrupole scanning functionality with sensitive linear ion trap scans, you can reduce analysis time and get more information from every experiment. It is used for the determination of new age pesticides, vitamins, amino acids, mycotoxins from food and environmental samples. The dioxin analysis system is formed of a Dionex AS350 accelerated solvent extractor, a sample cleanup system, and a gas chromatograph coupled with mass spectrometer. It is used for the analysis of dioxin from food and environmental samples, which are a group of chemically related compounds that are persistent environmental pollutants. They are mainly byproducts of industrial processes, but can also result from natural processes, such as volcanic eruptions and forest fires. Dioxins are of concern because of their highly toxic potential. The Sherlock microbial identification system represents a rapid, accurate, and inexpensive solution for the identification of microbial species from soil, considering fatty acids and phospholipids-derived fatty acids by gas chromatographic analysis. It is formed of a gas chromatograph, a freeze dryer, an autoclave, and an end-over-end shaker. The Spectromax microplate reader measures soil microbiota catabolic activity with targets on amines, amino acids, carboxylic acids, carbohydrates, phosphate carbon, and other complex carbon sources consumption. Analysis also involve a Spectromax, an autoclave, an ultrafreezer, and a microorganism incubator shaker. X-ray diffraction is the method of choice for extracting structural information from virtually any type of sample, regardless of shape, size, or composition, under ambient or non-ambient conditions. Bruker D8 Advance is a system that guarantees superior quality results, the shortest possible measurement time, the highest analytical performance, and offers information about phase composition, phase transition, amorphous content, percent crystallinity, crystallite size, lattice parameters, crystal structure, symmetry coordination, and order-disorder. The Pinnacle 900T is an atomic absorption spectrometer which includes in a single instrument flame and furnace atomization system with the high flexibility to switch between flame and furnace in seconds. Thus, it provides capabilities for measuring metals with very good specificity, characteristic atomic absorption spectrometry on a wide range of concentrations, parts per billion level using furnace atomization and parts per million level using flame atomization system. Hollow cathode lamps or electrodeless discharge lamps are used specifically for quantitative analysis of metals in environmental and food samples. The automatic methane potential test system 2 is used for conducting various anaerobic batch fermentation tests. This includes performing with up to 15 vials, biochemical methane potential tests, anaerobic biodegradability studies, specific methanogenic activity assays, as well as conducting residual gas potential analysis of digested slurry. The gas endeavor allows users to measure low gas volume and flow whenever there is a demand for highly accurate and precise measurements. The instrument can be used for research and industrial applications related to animal nutrition, wastewater, ethanol fermentation, hydrogen production, greenhouse gas emissions, evaluation of microbial communities and their activity, and more. The bioreactor simulator is used for simulating anaerobic fermentation processes in a continuous mode of operation. The system is controlled by a web-based software running on an on-site server or a remote cloud solution. The high quality of the data obtained from the bioreactor simulator allows users to gain deeper knowledge for determining the suitability of a potential feedstock for biogas production, defining the suitable organic loading rate or retention time for a given feedstock, designing suitable feeding schedules, and assessing handling or disposal conditions for digested residues. The Total Organic Carbon Analyzer allows the fast and precise measurement of organic carbon from various liquid, drinking water, surface waters, seawaters, wastewater, industrial effluents, and solid, soil, sediment, sludge samples in a wide concentration range, enabling the rapid assessment of water pollution with organic compounds and of soil quality. Mobile laboratory that monitors air quality, nitrogen monoxide and nitrogen dioxide by chemiluminescence, sulfur dioxide by ultraviolet fluorescence, carbon monoxide by absorption in infrared light. What's more, the mobile laboratory has a high-volume aerosol sampler, which can sample dust and aerosol particles for later assessment and analysis. Changes in weather and environmental conditions are registered by a meteorology module. Due to its exceptional team and technical infrastructure, the Institute obtained remarkable results following several lines of development, among which there can be mentioned: validation and implementation of laboratory analytical methods, processing technologies for obtaining different types of biofuels, environmental quality assessment of water bodies for several catchments, Ariés, Somes, Arges, Certej, and brownfields, Baiamares, Latna, Copșamică, impact assessment of climate change on soil microbiodiversity, and publication of research articles and books, and participation at national and international conferences. Research is a perpetual journey. Questions usually lead to new ideas, revisions, and improvements, providing information and knowledge needed for problem solving and making decisions for the benefit of the entire community.